Good day, students. On this clip, we're going to be going over two examples using the law of sines. As you can clearly see, the law of sines are used to start the solving of triangles that are SAS or SSS, okay? All right, so let's go ahead and take a look at, write down the instructions for the examples. So we have to solve each triangle, okay? All right, let's take a look at question number one. So question one, we have a triangle where angle B is 113 degrees, side C is 30, and we have side A having the measure of 22 units. All right, let's go ahead and sketch the graph of the situation, make a triangle. So let's just sketch a typical um, obtuse triangle. So this is A, big A, so this has to be little a. Let's call this big B, and this will be little b, and this is big C and little c. All right, putting in the measures, big B is 113 degrees, as indicated here. Little c is 30, and little a is 22. All right, so we need to find little b, we need to find big A, and we need to find big C. All right. All right, so we can clearly see that this is an SAS situation because we have side, this side right here, C, an angle, which is 113B, and another side. We see that continuum happening here, side, angle, side. So this is a situation where we use law of cosines, okay? It's impossible to make use of law of sines here because we do not have any pair. And it is not possible for us to find an angle that will make it possible for us to have a pair. Okay, so this is the only choice we have. All right, so which of the law of cosines are we going to select out of this three? Out of the three of them, we have two s's here, so we're going to pick the one that has the two s's, okay? So just to refresh your memory, these are the three laws of cosine. We have a squared equals b squared plus c squared minus 2bc cosine A. This is the first one. You also have b squared equals a squared plus c squared minus 2ac cosine B. And then you have c squared equals a squared plus b squared minus 2ab cosine C. All right? So which of these are we going to select for this problem? The one that has angle B, or C and A, and that is the second one right here. Okay? So the easiest way to determine the right formula to select is to look at the angle, because this formula, each formula has exactly one unique angle. This has angle B, so that's why we're going to select this one. All right? So we're using the formula. Let's write it down here. B squared equals a squared plus uh, c squared minus 2ac cosine B. Okay. All right, now let's put in our measures. We have b squared equals 22 squared for A plus 30 squared for C minus 2 times 22 times 30 cosine of angle B, which is 113. Okay? All right, let's plug this into our calculators. So we're gonna have, let me set my mode to degrees real quick. We're gonna have 22 square plus 30 square minus 2 times 22 times 30 times cosine 113. All right, enter, and our answer is 1899.7651. All right, so we have b squared equals 1899.7651. But we're looking for b, not b squared. So what we do is we'll take the opposite of square, which is square root. We'll root both sides. Okay. So when we root both sides, we're gonna have b equals. Just calculate what the square root of that is. The square root of, to be accurate, I'm gonna call on the previous answer by pressing second function negative to access the answer menu. All right, square root of answer is 43.5862. So there is 63, sorry. So that goes the measure of side B. So side B is 43.5863. All right, we have one down. So let's put that here. Angle side B is no longer a question mark. We know what it is now. Side B is 43.5863. All right, next, what are we going to look for? Now that we have a pair, big B and little b, we can now use the law of sines. Okay, so now we're going to use the law of sines. I should have written find little b here. So we're going to use the law of sines to either find big A or big C. So let's go ahead and find big A, okay? So we want to find big A. All right, so our setup is as follows. Sine big A over little a, since big A is what we're looking for, equals. The next pair, we need to know the big and the small, okay? So B satisfies that requirement, so sine big B over little b, all right? Now let's make the substitution. We're going to have sine A over little a, which is 22, equals sine b, sine 113, over little b, which is 45, actually 43, 43.5863. To get sine a by itself, we'll multiply both sides by 22. So multiply by 22 both sides. When we do that, we're going to have on the right side, on the left side, 22 is divide out. Sine A equals, now we're going to plug in the right side into the calculator. So we will have parentheses 22 sine 113, close the sine argument and close the numerator, divided by our previous answer. I'll use second function negative to call up my previous answer for accuracy. Enter. We have 0.4646. So sine A equals 0.4646. Now to get A by itself, we'll take the inverse sine of both sides. So let's go ahead and do that. We take the inverse sine of sine A equals the inverse sine of the result we just got, which is 0.4646. On the left side, the sines and the inverses cancel out, so we have A. Now we're going to go back to our calculators and compute the inverse of this result. So second function sine gives me access to the inverse sine of our previous answer, and the result is going to be 27.6856. All right, so angle A is 27.6856 degrees. Okay, now let's go ahead and find the measure of angle C. That's the only option that we have left. Find big C. We know that A is 27, is approximately 27.6856. So we can see that we have two angles on a triangle. So how are we going to figure out angle C? We're going to use the triangle angle sum theorem, right? So that's going to be, angle C is going to be 180 minus 113, which is the measure of angle B, plus 27.6856. So angle C, actually, this is going to be an approximation, is approximately, let's go back to our calculators. It's going to be 180 minus, parentheses 113, plus angle A, we have it as a previous answer, so I can call it back up right there. And the answer is 39.3. Okay, so angle C is approximately 39, 39.3143. Okay, let's write that down. 3143. All right, so there goes our measures. Okay, so let's organize them in a list. We have little b is approximately 43.5863. Big A is approximately 27.6856 degrees. And big C is approximately 39.3143 degrees. So there you have it. Okay, let's go ahead and consider question number 2. Question 2, we're gonna, same thing, solve. But in this case, we have a little b equals 26, little c equals 24, and little a equals 17. Okay? All right, let's go ahead and make a sketch of the situation and label it. Okay, so there goes our triangle, triangle ABC. All right, so let's call this big A and little a, big B and little b, big C and little c. All right, in this case, we know that little a is 17, little b is 26, and little c is 24. This is an SSS situation because we have just three sides, S, S, S. So the only formula that has three sides without an angle that has three sides is the law of sines formula. Okay, so law of cosines formula. Sorry. So um, all three formulas that for law of cosines will have three sides in them, so we can pick any one that we need to find an angle. All right. So our choices that we looked at before in example 1. You notice they all have three s's, so we just have to determine which angle we want to find. So let's pick angle A. Let's find angle A. So we want to find angle A. We're going to pick the formula that has angle A in it. And there's only one formula that has angle A in the law of cosines, and that is A squared equals B squared plus C squared minus 2BC cosine A. All right, so this will help us find angle A, and then we'll use law of sines to figure out the other angle. Okay, so let's go ahead and populate the variables with their values. So we have 17 squared equals 26 squared plus 24 squared minus 2 times 26 times 24 cosine A. Okay, we're looking for A in this problem. All right, now I want to, instead of simplifying, I want to get cosine A isolated first. So I'm going to subtract 26 square and 24 square from both sides. Subtract 26 square, 24 square. So we're going to have 17 square minus 26 square minus 24 square equals negative 2 times 26 times 24 cosine A. And now to get cosine A by itself, I'll divide both sides by the coefficient of cosine A, which is negative 2 times 26 times 24. Let's go ahead and do that. So divide the left side by negative 2 times 26 times 24 to get cosine A by itself. And on the left side, negative 2 times 26 times 24. So these divide out. And using the reflexive property of equality, I have cosine A equals 17 square minus 26 square minus 24 square um, divided by negative 2 times 26 times 24. Okay? All right, let's go ahead and plug this into our calculators. We're going to have 17, well, let's put this in parentheses. 17 square minus 26 square minus 24 square divided by parentheses. Use this negative, not the minus. So negative 2 times 26 times 24. Close that. Enter. 0.771.63. Okay. All right, so let's write that down, 0.771.63. So cosine A is 0.7716. Now to get A by itself, we take the inverse cosine of both sides. So the inverse cosine of cosine A on the left equals the inverse cosine of 0.7716. So we have A equals, think back our calculators, the inverse cosine of our previous answer, call that up, enter, 39.4991. All right, so angle A is 39.4991 degrees. All right, so let's go ahead and put that back in there, 39.499. So now we want to find angle B or angle C. Let's find B. In this case, we can use either the law of cosine or the law of sines. Okay, we have two choices here. We can see how long and involved the law of cosine was. So I'll rather use law of sines to figure out this one. Okay, so to find angle B, um, I'm going to go sine B over little b equals, the other ratio I know is sine big A over little a. Okay? All right, let's put in the measures. So we're going to have sine big B over little b. Little b is 26 equals sine big A, which we just found as 39.4991 over little a, which is 17. Okay? To get sine b by itself, multiply both sides by 26. 26. And then we have sine b equals, let's plug that into our calculator, in parentheses 26 sine, the previous answer, close the sine argument, close the numerator, divided by 17. And your answer is 0.9728. Okay, so sine b is 0.9728. All right, to get b by itself, we take the inverse sine of both sides. So the inverse sine of sine b equals the inverse sine of the result we just got, 0.9728. On the left side, the sine and the inverse just cancel out. And then we have b equals, and then let's plug that into our calculator. The inverse sine of previous answer, enter, 76.6077. All right, so let's write that down. Angle B is 76.6077. All right, so there goes angle B. Now to find the last angle, which is angle C. Angle C, let's go back to our triangle. And we know big B is 76.6077. So to get angle C, we can just simply use the triangle Angaston theorem here. All right, so big C is approximately 180 minus angle A, which is 39.4991, plus little b, which is 76.6077. All right, plug that into our calculators. We're going to have, let's do this, 180 minus our previous, actually 39.4991 plus, I'm going to call up my previous answer, enter, we have 63.8932. Okay, so angle C is approximately 63.8932 degrees. All right, so there goes all our answers. So we have big A is approximately 39.4991. Big B, angle B, is approximately 76.6077. And big C is approximately 63.8932 degrees. All right, so there you have it. Solve, solve the, the triangles, or the given triangles. Solve the given triangles and round your answers. Round your answers to the nearest hundredths. Okay. Now to solve basically means we have to find all the measures that are not given. That's what solving a triangle means. So for question number one, we have a triangle with measures angle A equals 30 degrees, angle B equals 50 degrees, and side length B equals 30. All right. Okay, so we're gonna go ahead and solve this. We have capital A, capital B, and little b, so we need to find little a, capital C, and little c. All right. So first thing we want to do is we want to draw a triangle. We're gonna draw a scaling triangle and populate it with the measures that we're provided with. Okay. So let's draw a triangle for ourselves. Draw a triangle of this nature. Now the way this triangle is labeled is extremely important. Okay. You have to make sure that similar letters are opposite each other. Okay, so capital letters represents the angles, and then the small letters represent the sides. Okay, so if I call this capital A, this angle is capital A, 30 degrees. You put the degrees on the inside, and that automatically means the side opposite it is side length A. Okay, side length A, we do not know, with a question mark. All right, and then capital B represents this angle. You put the measure on the inside, 50 degrees. Uh, and take that out of there. It's 50 degrees. And then side length B is 30. We know that. And then for C, this is capital C. We do not know what this measure is. Neither do we know what this measure is. This side opposite angle C is side C, and we do not know what the measure is. Okay? So to solve this triangle basically means we have to find the value of little c, little a, and big C. All right, so first of all, ask yourselves which side or angle is the easiest to find. If you think about elementary geometry, it's easy to find the third side of the interior angle of a triangle given two angles, right? So we're going to find the angle first. So let's find angle C. Okay, what we're using is called the triangle Angaston theorem, which tells you that the sum of angles in a triangle is 180 degrees. All right, so to find big C, all we just simply do is subtract the sum of all the angles, which is 180, from these two angles that we know, 180 minus 30 plus 50. Okay, if we do the arithmetic, we'll have angle C equals 180 minus 80, and that tells me that angle C is 100 degrees. Okay, so angle C right here is 100 degrees. Scratch that out. Okay, good. We have one piece of information. Now let's go ahead and find the other two. Now the other two are not as easy as this to find. We have to make use of trigonometric tools to figure them out. All right, so what do we want to find next? We can find little a or little c. In order to find any of these, since I have one pair angle on the side that I know, then I can automatically use the law of sines. Okay, we know what the law of sines are. Law of sines, we have, it is a over sine A equals b over sine B equals c over sine C. You use two at a time, or another variation of this is sine A over A equals sine b over b equals sine c over c. They basically mean the same thing. All right. So what are we looking for? How about we look for a first? Okay. So let's find a. Okay. So if we want to find a, I'm gonna start out my formula by writing what I'm looking for, which is a. I'm gonna write a over sine of the angle opposite a, which is a. Now this is the ratio that's the pair that I'm missing a measure, namely a. So the next pair I have to pick, I must know the side and the angle. Okay, I must know the pair both sides. So that's why I said since we have a pair that we know here, we can use the law of sines because it's required. So since I know b, big B and little b, the formula I'm going to use is a over sine a equals little b over sine big B. Okay? Alright, when I substitute, I must have only one unknown in my equation, or else I can't solve it. So let's go ahead and make a substitution. Um, little a is unknown over sine, angle A is 30 degrees, equals little b is 30 over sine, big B is 50. Okay? Can I solve this equation? Absolutely, because I have one equation and one unknown. Alright? So how do I solve this equation for little a? I need to get rid of this denominator, so I multiply both sides by sine 30. Multiply this by sine 30, multiply this by sine 30, this divide out, and your answer is going to be a equals 30 sine 30 divided by sine 50. Okay, so we're going to plug that into our calculators to get our approximate result. So let's bring out our calculators. Make sure that our mode is set to degrees. Let me go ahead and fix that real quick because our angular measures are in degrees in this problem. So we're going to do parenthesis 30 sine 30, close that, divided by sine 50. I have only one argument in the denominator, so I'm going to put parentheses. Enter 19.58 to two decimal places, so it's approximately 19.58. So little a is approximately 19.58. All right, let's go ahead and look for the last side, which is little b. So let's find the partition my works. Just scroll down. Let's go ahead and find little b. Actually, I know what little b is. I need to find little c. Okay, so to find little c, let me set up the equation first. So to find little c, I'm going to use law of sines again. I'm going to go little c, which is what I'm looking for. I like to write what I'm looking for first, over sine big C equals. Now I have two choices. Since I know little a and big A, I can use that. Since I know little a and big A, I can also use little b and big B. But the problem with little a is an approximation. So our answers won't be too accurate. Besides, it could be wrong also. So it's safer for me to use little b and big B since I was given that in the problem. So I know for sure that it's going to be accurate and they're exact values too. So it's smarter for us to use little b over sine big B. Okay? So that's what I'm going to use here. All right. With that in mind, let's make our substitution. We should have only one unknown, and this since we have one equation. Little c, we do not know what it is, over sine big C is sine 100. That was the first answer we found. Equals little b, which is 30, over sine 50. Okay? Now to get big C by itself, you multiply both sides by sine 100 so that you can get rid of this denominator here. Sine 100. So this divide out. And then you have C equals 30 sine 100 over sine 150. I mean sine 50. Okay. All right. Now we're gonna plug that into our calculators to generate our approximate value measure for side C. All right. So let's plug that in. So we have third. Let's put in parentheses. Parentheses 30 sine 100 close the sine argument, close the numerator, divided by sine 50. Okay, and then your final answer, we're going to write 38.57 to two decimal places. So C is approximately 38.57. All right, so there you have it. Okay, so let's organize all our answers in a list so that we make sure we have everything down. So for this problem, we have for solutions, we have big C equals 100 degrees. Little c is approximately, let's try that again. Little c is approximately 38.57, and little a is approximately 19.58. All right, so there goes your answers. All right, let's move on to question number 2. All right, for number 2 is exactly the same instructions. We're gonna solve a triangle with the given measures. So let's write down the measures. So for number 2, we have angle A is 65 degrees. Angle B, big B, is 50 degrees. And angle C is 12. All right, so let's go ahead and make a sketch of the situation so we can label our triangles correctly and set up our formulas accurately also. All right, so let me draw myself a triangle of this nature. It's not perfect, it's just a sketch. Um, Angle A, let's call this angle A. 65. Remember, the little letter goes opposite the big one. So if this is big A, this is little a right here. I don't know what that is. Um, let's call this angle B. And angle B is 50 degrees. So this is angle B, the side opposite angle B has to be little b, okay? And then this is angle C, I don't know what that is. Side opposite angle C is little c. We know that that's 12 units long, all right? So we can see in this problem, we need to find little a, little b, and big C. All right, so what can we find first? Um, the easiest thing to find is angle C using the triangle Anglesey theorem. We cannot even use the law of sines here because we do not have a pair that we know. Okay, see this pair, we don't know both of them. We don't know both of these, and we don't know both of these, so we can't even use law of sines. So the only thing we can find first of all is angle C using elementary geometrical tools. Okay, so let's find big C first. So to find big C, we know that the sum of angles equals 180. So C is simply 180 minus the sum of the other two, which is 65 plus 50. Okay? And then when we do the math, the arithmetic will have C equals 180 minus 115. When you subtract the 2, you have 65 degrees. Okay, so angle C equals 65 degrees. So there goes the measure of angle C. All right, now we can start figuring out the measures of the sides. Put that there, 65. Okay, so we can either figure out A or B first. It doesn't really matter. Um, how about we figure out uh, side A? Okay, so let's find A. So to find A, we're going to use law of sines. Well, why can we use law of sines now? We can use law of sines now because we have a pair, a side measure of a side and the angle opposite the side. So we can use law of sines to find the missing side. So I like to set it up using what I do not know first. So it's a. So I'm gonna write a over sine a equals. Now the next ratio I must know the pair. Okay. So which is c and big C. Little c over sine big C. Okay? Now let's make a substitution. I must have only one unknown in my equation or else I can't solve it. Alright, so little a I do not know over big A is 65 over sine 65 equals little c, which is 12, over sine big C, which I just found as 65. Okay? Alright. Alright, so to get little a by itself, I will multiply both sides by sine 65. Sine 65. So this divides out, and then that yields a equals 12 sine 65 over sine 65. Okay? We don't need a calculator to do this because you notice that the sine expressions are identical, so we can just divide them out. So sine 65 goes here once, sine 65 goes here once. Your final answer A equals 12. Alright, so there goes the measure of one side. Now we need to find the other side, namely little b. So let's go ahead and do that. So we're going to find little b. Okay, alright, so to do that, we are going to use the law of sines again because we have a pair that we know. So I like to start off with what I do not know, which is little b. So little b over sine b equals, now the next pair I select, um, I have to know it, the big and the small. Okay, so let's see. We can use A or B. We can use A or C. Um, they are both nice figures. They haven't been approximated, but since this is part of the original question, let me just use C. Okay, so I'm gonna use big C and little c. So over little c divided by sine big C. Okay, so let's make the substitutions. Now we have little b over sine big B. Sine big B is, let's see what sine big B is. Big B is 50 degrees, so sine 50 equals, little c is 12 over sine 65. Alright, so to isolate little b, we'll multiply both sides by sine 50. Sine 50, sine 50. So that gives us little b equals 12 sine 50 over sine 65. Okay? Alright, so we just plug that into our calculators, and that will give us our answer. We'll round it to two decimal places. So let's do it. We'll have parenthesis 12 sine 50. Close that, divided by sine 65. Final answer is 10.14. So our answer here is going to be 10.14 to two decimal places. So B is approximately 10.14. Alright, so let's go ahead and organize all our three results in a nice list. So our solutions are solutions, big C is equal to 65 degrees, little c is equal to little a is equal to 12, and little b is equal to, well, actually little b is an approximate result, so little b is approximately 10.14. So there you have it.